Okay. Now, given a graph, and we'll just put this as big and on top. So, given a graph. Okay. A walk from V to W is a finite alternating sequence of adjacent vertices and edges of that graph G. Okay. Okay, so just walking from V to W. We don't have any restrictions on this one. Okay. And now, technically, this one says it's an alternating sequence of edges and vertices. Going from V to W, I'll show you one in a minute where you don't necessarily have to have an alternating sequence of adjacent vertices and edges. You can just have a sequence of vertices or a sequence of edges. But there's some ambiguity if you just do vertices or edges because you can't always identify what the correct walk would actually be. Okay. Okay, so that's a walk. We're just going to walk from V to W. A trail from V to W is a walk with no repeated edges. All right, and this is going to be some of the restrictions that we're going to put on these definitions in class today is, well, what if you can't have a repeated edge? Well, what if you can have repeated vertices? So we can have a trail, meaning no repeated edges, or a path from B to W is a walk with no repeated vertices. Okay. Just got 3 more definitions. So we have a walk. A trail is a walk with no repeated edges. A path is a walk with no repeated vertices. Another way to describe a walk. A closed walk is a walk that starts and ends at the same vertex. So if you have a closed walk, whenever you're walking around your graph, if you get back to where you started at the very beginning of your walk, that's closed. Okay? So we're adding extra conditions on here, right? So besides a closed walk, a circuit is a closed walk that contains at least one edge All right, now what's meant by a circuit, that you have to have at least one edge and you cannot repeat an edge. So if you wanted to consider a closed walk in simplest concept possible, what if you didn't go anywhere? And you say to me, well, this one says you have to have at least one edge, okay? It also says you can't have any repeated edges. So you can't have just like one edge, go to the next vertex, and then go backwards to where you began with. You need to actually walk around this thing and get back to where you started. So it means it would have to have at least 3 vertices. So that's a circuit, and now a simple circuit is a circuit that does not have any repeated edges repeated vertices. That would already be, the concept of non-repeating edges is already covered by the concept that it is a circuit, because a circuit has no repeating edges. So a simple circuit says, well, it's a circuit and it does not have any repeated vertices, except the first and last. Because you have to start where you began, so that vertex has to be repeated for it to be a closed walk. And a circuit is a closed walk.